Yep.
Yeah.
Okay. All right. So you remember we built this yesterday. We built the guessing game class, but we didn't hook it back up to the main activity. So now that we have that, let's start that process. So if I think about main activity and how I need to rejigger some things, basically what's happening now is I'm storing the state of the game is now being kind of owned, is going to be owned by the guessing game class. Well, so what does that mean? If that's owning the state, well, that means that these variables here are now basically going to be extraneous. Does that make sense? The random object then and these three variables, all of those have been moved over here. So I don't want to have those in both places, or I'm going to have duplicate data and all the problems that comes with that. Everybody with me there?
Yep.
So in a way, the unit test becomes an inextricable part of your app. You have to have it or it'll break.
No,
right?
no, that's not true. That's not true.
But
This guessing game is not the test. Guessing game is the test, is the class we are going to write tests for. But that is not the test. We haven't written any tests yet.
guessing game is not the test.
This is not the test. This is not the test. We haven't written any tests yet. Okay.
So this is a part of the app. Then we're just
This is
building
still
it out.
part of the app. This is still part of the app. We haven't gotten the test yet.
This is the divorce stuff you're talking about.
Right. This is the stuff that we have to set up in order to get to where we can test it.
Okay.
So we haven't gotten there yet. Okay. Because the way we started writing this, I wanted to start writing this kind of the way that you're used to, right? And then try to kind of revise it to something that can be tested. And so that's an important distinction, is that not everything can be unit tested. And in order for it to be unit tested, you do have to write your code a certain way, right? So that is really a skill to kind of understand how do you need to write your code such that it doesn't have dependencies on other things, so that you can test that as an isolated unit. Because guessing game, right, this class doesn't depend on anything now. Okay, and that was my goal. My goal is to come up with the class that contains the logic, but it doesn't depend on any other things in the system. So main activity now, though, on the flip side, is going to intricately depend on that guessing game logic. Does that make sense? Because what we're going to do is we're going to take all that logic, basically, that we had moved and remove it from main activity. Okay. So in here, I'm going to take all of those variables away and replace that by the single variable private guessing game. I'm going to call that variable game. So that game now contains all of the data, all of the state of the game, with the exception of the text that's being displayed currently on screen. Okay?
Yeah.
Maybe did you delete the previous guest and guest count settings
Yep.
0?
That's exactly what I just did.
Okay.
Right? So now you should only have those three variables. If you have anything else, you're going to have a problem. So that's what we're going to. And the reason we removed all that is because we've taken all four of those variables and put them over here. Does that make sense?
Yeah.
All four of those are contained over there now. Okay. So then, as far as I'm thinking about setting things up in onStart, well, when the application starts, I need to start a new game. So I'm just going to say game is equal to new game, new guessing game. Right? So I just need to instantiate a guessing game when the application starts. That's where that starts. Okay. And as far as the reset button is concerned, going down to reset would be the next thing. So there I'm going to say, let's say game, let's reset the game. and then it's just a matter of updating the text. So for instance, here we have, okay, we want to set the text to empty string, the guess edit.
I didn't understand.
That's not going to change, but we do need to change a little bit here on the outcome, because you see we were trying to show the secret number, right? But we don't have that variable here anymore. Right with me there? So where does that variable exist?
On the game.
Okay.
Doesn't it exist in the game class? Or the guessing game class?
Right, so now how do I get access to it?
Game that get secret number.
Sorry, sneezing here. Game dot get secret number. Right. So I want to say, pull it out of there, and we're going to display it here. So rather than it being an instance variable of main activity, it's now, it's an instance variable of game, so we have to use that getter to access it. Okay, so that kind of makes sense. And we can, I think I'm going to do this onGuess method last, because it's probably the more complex one to extricate. The next thing we want to look at is kind of staving and restoring the state. Well, in here I can kind of take that same approach, in the sense that I can just say game dot get previous guess, game dot get guess count, and I can just save each of these variables individually. So that's where I would start, is using those. Now there is a cleaner way to do this kind of logic with using bundles, using something called parsable. I'm not really going to I don't want to go into that right now, but just so you know, there is another way to do that. But the approach I'm going to take right now is to just extricate each of the variables one by one. Okay. Now, so that makes sense, right? But what do I need to do then on the restoring side? When I get back to restoring the state, how can I restore the state? What do I need to do for that?
Do we create setters in guessing game?
Okay, that'd be one way, right? We could create setters there. The problem then that opens up, it kind of breaks all of the encapsulation for the game, in that now anything can set those values, right? So I would generally want to avoid that where I can. So what's another option? That is one way you could solve it, but it's not. I wouldn't call it the most object-oriented way of doing it. Anybody? Thoughts?
Can you repeat that?
So we need to restore the game back to where it was, right? So, can I, what is an approach I can do that? So one option is to use setters. What's another option? Because yes, I do need to get the game into that state. What's another way you commonly pass data? Well, another way to commonly pass data is through the constructor, right? Remember that there's a constructor, right? So the way I would approach this, instead of adding setters, I would say it's better to add another constructor.
Oh, and you would call the on restore, huh?
Right. So this constructor is only going to get called from onRestore.
I was going to say that, but I didn't know if that was right or not.
Yeah. So in here, I'll add a constructor, and that kind of limits. Basically, it limits how much you can do in terms of like putting the game in maybe a bad state. So we can use this to restore the state, but we don't make that necessarily widely open everywhere. Now, thinking about how I need to set the variables in here, I will need to, for instance, set the random number generator. I'll need to just construct a new random number generator because I didn't save that. And there really wasn't a good way to save that. And then the other values I'm just going to save, like so. So I might say this dot previous guess is equal to previous guess. And you'll kind of remember from a previous lesson that we kind of talked about this. You have to use the word this because otherwise you're referring to the parameter here, which has the same name as the field. So that clarifies which thing you're referring to. Now, I didn't have to do that for rand. Here, it was optional because there's only one version of that variable. Does that make sense?
One version of that variable.
Right. There's only rand. There's only the instance field. There's only an instance field named rand. There's not a parameter named rand.
So that's it. Just rand equals new random.
Yeah. Now, if I wanted to be more consistent, I could totally write it as this dot rand is equal to new random, and that would be the same thing. The this is implied anytime it can figure out that there's not a parameter or a local variable by that name.
But the rest of it will break if you don't put this.
Correct. Because then I'd be setting this place in memory to the same thing, right? So rather than referencing this references the field and this references the parameter, I have to distinguish because there's what we call shadowing happening. There's shadowing happening because they both have the same name.
What if they didn't have the same name? Would you need this?
Then you wouldn't, but it's actually considered good practice in Java to name them the same.
Yeah, right. It eliminates redundancy.
Yeah, well, it eliminates other weirdness because if you use one name here and one name there, it actually gets weirder. But there's also some technologies and things that depend on those being the same name that you can't use if you don't follow that convention. So that's how I would solve the problem of being able to restore the data. Is I would add a constructor that can then set it back to that state. So again, setters is a viable option, and if you're doing things like the money tracker where you've got transactions, if you want to solve that with setters on the transaction, go for it. Or if you want to solve it with a constructor like this, go for it. Either one I would take. But this is a case where, because we're kind of talking about a game state, these three variables are kind of intricately connected. I don't want the user to just have free access to change those numbers to anything that they want. Okay. So then coming back here, what I would then do is I would say game is equal to new game, new guessing game. And then I would construct that object using the states that we saved. So pass all three of those in, bundle, guess count, and the secret number. So that's how I would change the code to save and load the data. Okay. Any questions? Everybody got that?
Yep.
Anybody still coding?
Yeah, 1 sec.
Okay.
What was the hotkey again to clean everything up?
What I do is go up code and reformat file, but that will not work right now because the code doesn't compile. Because there's syntax errors in the code, you can't really format it. So you'll have to do that by hand right now. Which is a good skill to know. Anyway. So you'll see a red unlearn line on main activity because we still haven't implemented the on guess method. We still haven't sorted that out. Okay. Corey, did you get that stuff in?
Yep.
Okay. Zach, are you caught up?
Yes, sir.
Okay. So now that we've gotten everything else, let's think about on guess. And so I did talk about this a little bit, on Tuesday, in the fact that there is some logic here that we can't move. That logic kind of has to remain here because it's intricately twined with Android and the UI. So for instance, anything that needs to reference to guess edit or outcome text, that code all has to happen here. So there is going to be at least there's going to be a good chunk of code that still ends up being here, and it's enough. It'll end up actually being enough that it may kind of look like, well, why did we do this? Because in the end, it's actually going to make the way we solve this, the code's going to actually look more complex. But the reason that we're doing it this way is because it follows something called separation concerns, where the idea is that you want your classes to be concerned with different kinds of problems and not concerned with, you want some division there. So what we've done is we've decided that the guessing game is only concerned about the business logic or the logic of that game. It's not considered with it doesn't know anything about how the UI is implemented. So I could take that guessing game, drop it in a completely different UI, and not change the code. And that. So details of the controls that we're updating, details about what strings are being displayed, what text is being displayed on screen, and what numbers are displayed in that screen is left to main activity. So main activity still has to deal with those details, including things like, checking and parsing the input. Okay? So if we kind of work our way from the top down, right? So line 30, we're grabbing the text that's in the guess field. And then we're immediately checking if it's length 0. This code all here, there's no way to move. So that code is going to stay here, and it's actually going to remain unchanged. What will change is all the code here, right? So this is all the code, all the logic that we were able to move because it's divorced from the UI. Does that make sense? This code up here, there's not a way to move because it's tightly connected with the UI. Cool?
Yeah, and this is not just separation of concerns, it's encapsulation. Are those the same thing or not?
Those are not the same thing. Those are not the same thing. You can have encapsulation but not have separation concerns. You can have separation concerns but not necessarily encapsulation. Although it usually, to implement the separation of concerns usually requires some level of encapsulation, generally speaking. But just because you've cleanly encapsulated your code does not mean that you've cleanly separated it. So, for instance, if I were here in guessing game and this method here, the guess method, if this were returning strings, it would not be following separation of concerns, because it would still know something about the strings that are being displayed. Or if it had a reference, if we said I passed in the edit text and the text view as parameters to this method, and then it updated those, well, that would not be following separation of concerns. Okay, so it would be still in this class is still encapsulated, because basically the encapsulation just means that these variables are private, and you can't directly access them, and that's where the not having setters comes in. So not having setters and marking these private, or requiring those to, requiring your code to go through these getters, that's the encapsulation part. The separation of concerns part is actually the more important part to be able to test. Because you can get all of the encapsulation right or wrong, and the way you do, whether you succeeded encapsulating or not, won't really affect your ability to test it. What will affect your ability to test it is getting the separation of concerns right. Okay? So the way I'm splitting this is, again, what we call business logic over in guessing game, and what we call presentation logic is over here in main activity. Okay? That deals with the UI. So up until this point, I've said, let's get the string, check that they actually entered something, and then finally parse it. So if we get to this point, we have a number that the user has entered, which I can finally pass on to the game. So from there, I can actually call the guess method. So here I will say, game.guess, and I can pass in my guess. Okay? So that's all I need to do in terms of invoking that method. Okay? Game.guess. Okay, so that invokes the business logic. Well, all right, so we've run the business logic, but what I don't have is if I just were to run it in this state, I'm not going to see any of the UI updating. And let me run it real quick just so we can make sure that we're kind of seeing the same thing, right? Okay. So if I hit guess with nothing in there, we'll see that it still says please enter a number. But if I say enter the number 4, what happened? Oh, it hadn't started yet. So if I guess that, but if I say enter the number 4, nothing happens. So internally, the game is tracking that and producing a result, but we haven't brought that back to the UI, right? So if we remember how this operates, it's going to return one of these enumeration values, either win, high, or low. And I'm using that enumeration to kind of limit and define the scope of the values that it can return. I could have returned that as a number. I could have said return 0, return 1, return 2, and then I would have to define what those special numbers are. Or I could have returned a string here, and maybe the string was win, high, or low. Problem with that is first of all, that lets there be potentially other values, but it also doesn't give me some documentation of what those values are. So by putting these into enumeration, basically what's happening here is we're giving this is actually become 0, 1, 2, but we're kind of giving it a name. Does that make sense? We're giving it a name, and we're saying it can't be anything other than those 3 values. Okay. So
I was just thinking, would use this seems like an opportunity to use a case and a switch here to.
It is a perfect case to do that. It is a perfect case to do that. Enumerations are very much meant to be used with switch statements. They are really, really meant to be used together, because they just work they work well that way. So do you have to use a switch statement? No, you don't have to. We could write this with we could write this with if statements, but there's a lot of benefit to using switch as soon as you get into enumerations. So in here, basically what we know is if we're just looking at this, we don't know the logic for when and why it's going to return those values. We don't really care. But I do know that it's going to return one of those three values. So I can tell it what to do if it gets a particular value. So I'm going to say, let's switch on the result. And so my first case would be win. And so if we get back a result of win, then that's where we would change the text to be that case. So we would say if it's win, then we want to use the winning text, and we want to put in the secret number and the guess count. Now, you'll see that those two numbers are in red. Everybody remember why those are in red?
You have to get them from the game object.
Right, because we don't own them anymore. So we're going to have to say game.get secret number and game.guess count. Okay. So a similar sort of way, if I say, you've got high, so we're going to say case high. Do remember the break statement after every one of those. And then that's where we would say, well, let's set the outcome to guess text high, break, case low, and outcome text, we're going to set that to guess load text. So at this point, we take the string that the user returned, and we turn it back into a value. Back into a string, basically. Questions so far?
Yeah, just need a minute to get caught up.
Okay, no problem.
Are you gonna post the rest of this code on Inside Ranken?
Not on Inside Ranken, but I'll put it up on GitHub. But I would ask that you code along.
Well, I missed something because my internet went out yesterday.
Mm-hmm.
Because they were doing my modem, so.
Well, I put everything yesterday. I put out both up on GitHub and here.
Oh, I didn't
Discord.
know you pushed it up. Okay.
I put it as a zip file. So.
No default case?
No default case is needed. And that's because we've kind of defined everything in guest result in this enum, so it's not possible for there to be anything else, right? It's not possible for the result to be anything other than one of those three. Technically, it could be null because the references, because in the Java world, enums are actually reference objects, or reference types. They're not actually an integer, which they are in most other languages, but that's something I'm just assuming that it's not null here. So, while people are kind of still finishing up there, I'm going to go ahead and try it, and we can kind of see what's going on. So first things first, when I run the program, I do see that nothing's appearing. Okay, so I do have a problem I need to resolve there, and basically that's because I need to call. I need to call those two methods. You say, let's set the guess edit, and we'll set the outcome text in onStart. So that way my secret number appears. Okay, so I can try a few different numbers. So I can say 2 and guess. It's going to tell me too low. I can go to 10 and guess. Tell me I got it. I got it in 2 tries. I need to get a different number, guess, and I got my too high. Right. So those things are working. Right. Are we done? Is there anything remaining that we need to do?
Don't we still need the unit tests?
Okay, we still need to do the unit tests. Is there anything that is broken right now? What have we not tested yet?
Rotation.
What do you mean rotation?
Like rotating the virtual phone.
Okay, so that's one of the things we haven't tested. Okay, so that seems to be operating.
A number that's greater than 10.
A number that's greater than 10. Yeah, so let's try 11. My application crashed. That's a problem. All right, so what do we need to do? Because my application crashes if I type in 11.
Well, the answer is going to be in the guessing game logic somewhere. We just got
Okay.
to start there.
Is it going to be? How do we know?
Well, we're evaluating what's been entered,
Okay.
and that's relevant to the guessing game because you need to know
Okay.
the whether it's too high or too low will be dictated by the business logic. 'Cause
Right.
We have 1 to 10, but it could be
Okay.
1 to 100. So you
So,
can't do that
Paul,
on the front.
Let me stop you there. So you're making an assumption, right? It's in the guessing game, but you have no evidence, right? So on Monday, we talked about how to get some evidence before you go wildly looking, right? So we should probably use those tools to figure out where the problem is, right? Rather than just guessing at where the problem is. You with me?
Not yet.
Okay. What did we learn on Monday?
Oh, Monday. I just
Anybody-
remember yesterday.
Okay. Somebody else can chime in. What did we go over on Monday? Don't tell me you forgot everything already.
Well, we started 3.1, right? I mean,
Okay.
that's what we did. I
did
don't
3.1.
remember like in particular. I just kind of think of it as one big blob of activity.
Okay.
We did the debugging stuff.
We did debugging, right? So we looked at how to use the debugger as well as how to look at how to mess around with Logcat. So what can we do? Can we use the debugger to solve this problem? Probably, right? So a good hint to go start with, we could put a breakpoint on line 32 and run the program with the debugger attached. So hitting the bug, going in here, and we can see what is actually going on, right? So if I type in 11 and hit guess, right, we can actually track through and see why it's crashing, okay? And we should do that before we try and fix it. You with me? Because what happens is if you try to fix a bug and you do not understand what caused it, what inevitably will happen is that you haven't fixed the bug. More than likely, you won't have fixed the bug. You'll just have made the bug harder to reproduce. which makes your future self or the next developers work harder. Does that make sense? So we want to fix the bug so it doesn't happen again. All right, and to do that, we need to understand why it occurred. Okay, so if I start here, right, remember the basic process we can do. First of all, we can just kind of step over the code, and we can see where it goes. Okay, so we're in here. It's a good number. We can expect that. I'm going to go into here, and so at least before it's got into game.guess, everything's good so far, right? So if I then step over that line, oh, something happened, right? I left my code and I went somewhere else, right? So somehow we're here in this thing that says invocation target exception, right? Everybody see that?
Something went wrong.
Something went wrong. Okay, so let's go back and try to dig into it further, right? So I'm going to type in 11 again and go guess. Now, we've determined in here which line of code threw the exception. Which line of code was that?
I thought it was 37, yeah?
Okay, so we've determined that line 37 is our culprit. So in fact, I can just put a breakpoint on line 37 and just tell it to go there. Okay, so we're going to go to line 37. All right, so that's where I'm then going to step into that line, and we're going to find out what's happening. Okay, so I go in here, and actually the first thing it does is check, is the guess less than 1 or the guess is greater than 10? So as it turns out, yes, the issue, the exception is being thrown from guessing game. Okay, and so the guessing game is throwing this illegal argument exception. Okay, so that's why that's where the exception is being thrown. But let me ask you this: is that acceptable that that this is throwing an exception? Is that desirable?
No, we'd want to try and catch.
Mm-mm.
Yeah?
No. So the catch is part of how you deal with an exception, but the requirement, if we say the requirement for this class, this is to model the business logic. Throwing an exception here and letting it not be caught is perfectly okay. Okay? Because this is just saying, hey, there's something wrong. When you throw an exception here, I'm saying something is wrong. I'm not going to deal with it. You have to deal with it. Does that make sense? So guessing game is saying it's not responsible for handling that exception. Everybody with me?
Yeah.
Okay. So oftentimes, and again, this comes back into this idea of separation concerns, the reason I'm throwing an exception here is because it's not really the job of this class. This class is saying, my contract, basically, its contract is saying, if you give me a value that's out of range, I'm going to throw an exception. Okay? So that's a decision that's been made when we wrote guessing game. And so I could go back and change that. And one way I could resolve this is I could say, let's just return another value. Here I could say return guess result and define out of range. And so we just add another case for that. So that would be one way I could resolve that, is just by saying let's return something different. But a lot of times there is value to throwing an exception instead of just returning a value. Okay, so I do want to go into kind of where that fits in. So remember that this is throwing the guessing game is throwing an exception. That's okay, right? But remember what method called it, right? So what method called guess? It was the main activity. Right? Main activity on guess, right? So the place where we want to do the try catch is not in the same place that it's thrown. Everybody with me there? It's very unusual if you're throwing and catching the exception in the same method, because at that point you usually don't need to do it.
So the exception is thrown in the guessing game class. It's a
Right.
way of getting the developer's attention because
Right.
it'll crash the program.
Right. So
Okay.
so that's the point, that the function, the thing that called it needs to do something, right? So because it didn't do any range checking there, we're coming in here. So the way I would handle it then is I would handle it here, and I would put a try catch around this. And so my try catch at least has to be around that line of code. It doesn't necessarily have to be around anything else. But the problem is, can I run this switch if I don't have a result? Does that code make any sense?
No.
No. So because of that, because it's dependent on that, I'm also going to move it all into the try as well, because that's dependent on this operation going through. So I'm going to move the catch all the way to the end of the switch, and there I'm going to catch the illegal argument exception. So in that case, we know the legal argument exception gets thrown when it's out of range. That's where I would then set the outcome text to that guess out of range text.
Is there any chance we can pause here for a second while I catch up?
Yep. Absolutely.
The way that you would know which
Mm-hmm.
to put in the catch block, the error,
Mm-hmm.
that comes from stepping through and just seeing what happens.
Mm-hmm. Yeah.
Otherwise, you could maybe take a guess at what it is, but that's
Right.
all it would be, and maybe you get it right. But
Yeah.
if there's another type of, say, like a null reference exception,
Yeah.
it would just crash just the same. Yeah.
It would crash. I would put I would do one of two things. I would either put in another catch here for that case, or I would prevent it from happening in the first place. And generally, the other answer for when it comes to null reference exceptions, you should pretty much always prevent it from happening in the first place. So if you're getting a null reference exception, that usually means you don't have an if statement somewhere where you should have an if statement.
Like dot length equals 0, something like that.
Yeah, something of that sort. Checking that the guess string is not null, or that checking that the control is not null, or things of that sort. So generally you shouldn't put in things to say, well, catch a null reference exception. You should generally write in your code in such a way that it can't happen.
Yeah, something came up last night. I was trying to test for negative numbers on,
Yeah.
I can't remember which one of them.
Mm-hmm.
There was no way to enter a negative number
Okay.
or a decimal point. Is that normal?
That depends on the type that you assign to the type that you assign to the input box.
Yeah, I think it was just number, nothing else.
Right. Yeah.
The only way I could get it to work, I couldn't select it with the flag.
Uh-huh.
The only way I could do it is to hard code it in the XML. It just wouldn't select otherwise. It kept wanting to divert to number, decimal, or one of the other types.
Once people get this typed out, I'll show you real quickly how to test it. But this is that's actually another strength of unit testing, is you can test some cases that may or may not be possible through the UI.
Yeah, I'm caught up, by the way.
Okay. So the reason that it's not letting you type in negative numbers, or it's not letting you type in some of those things, is down to in activity main. We have set it to the edit text is just type number. So there's some other types that we could have set it to. So for instance here, I could go change it to, and you don't need to change this because we're going to leave it at number when we're done here. But I could have changed it to number signed, hit apply. Number signed includes negative numbers. So if I just change that type, I'll be able to type in, say, -1.
Okay, and the way you got it set up too, you can put floats in there. I couldn't do that. There was not even an option to put a decimal point in,
I can't.
even though it's on the keyboard.
Yeah,
Oh,
even though
okay.
it's on the keyboard. Even though it's on the keyboard. If I want to get access, it's the same thing. If I want to get access to that, I also have to check number decimal. So number decimal's got to be checked in order for that flag's got to be set for you to be able to type in decimals. So now I should be able to type in, say, 2.5. Because I've set those flags.
Yeah, and negative would work too.
All right. So that number sign lets you put in negative numbers. Number decimal lets you put in numbers that are not whole numbers. And if you were to then, let's say we change it to text, and hit apply, and just go to text, well, that's where, you're going to be able to type in letters, and you're actually going to get a different keyboard here. See?
Oh, right, yeah. So you just want to prevent as many errors as possible with the keyboard.
Yeah, exactly. Yeah. So that's where they give you those options, is you can limit what keys actually work on the keyboard to A, prevent errors, and B, kind of give the user a hint as to what you're looking for.
Would you be able to, with a number keyboard of any kind, would you be able to paste letters in there?
I don't believe so. I think the one that comes out of the box already removes that possibility. So I believe that logic's already built in. So that's basically that's the reason I'm saying number, is because I only want positive number, positive integers, and that's the case here. Okay. So the type you pick is really, should be based on your particular requirements there. Okay, so we've got that. We've got all of the code in place. I hope what you can see here is that there's now this separation, right? So there's a separation between the stuff that interacts with the UI and the logic that runs the game. Does that make sense? None of this logic is game logic anymore. It's just simply dealing with input and output. Cool? And you'll notice that guessing game has no reference to any views. Okay, so that's what I needed to get to. All right. So now that we have that in place, this is where we're actually going to go over and write our tests. Okay. So our tests don't go into the main folder. They have to go into this test source set, is what we call it, is a source set. Okay. So under guessing game, I'm going to right click that, the test source set there. I'm going to create a new class. And I think I have to start with Java class. So I'm going to start with Java class here. Yeah, I don't see a template for a test unless it's under other. Nope. So Java class. And so this is going to be my guessing game test. So we normally take the name of the class that we're testing and add the word test to the end. That's the convention. Okay. So they have very similar names, and that way you can kind of know which test goes with which class. Okay. So this is going to be where we're actually going to put our tests. Okay. And so from yesterday, you'll remember I need to add a few annotations to make this work. So the first annotation I need to add is run with. and then I need to tell it which test class runner to use. So we're going to use the JUnit4 runner. So I'm going to put JUnit4.class up there. And you see it's kind of added some reference there. Org JUnit runners run with, org JUnit runners JUnit4. So that's the first thing I need to set up. Now, within there, I'm going to set up my individual testing methods. Okay. So I need to set up, first of all, I do need to set up the state of the game. So for all of these tests, I want to have a game that I can kind of work with. So we're going to say guessing game. And this I'm going to have as a variable here, as an instance variable. And then I need to have a method to start that up. So public void, and maybe I can call that start. You can call it setup. You can call it anything really you want, as long as it's got the start annotation. And I feel like I'm missing something. Oh, it's before, not start, before. Yeah, so maybe I'll call this my before method. Yeah, okay. So this is going to be the thing that we're going to run before the tests. So before the tests happen, I want to make a new game. And that game, I want to actually give it some initial state. I actually don't want to necessarily start it all the time with 0, 0, 0. So to make this easier, rather than having it randomly pick a number, I'm going to just say, well, let's start it at number 5. So I'm going to fill that in as my secret number. So previous guess 0, guess count 0, and secret number 0. Sorry, secret number 5. Does that make sense?
Yeah.
Okay. So that's kind of my setup, right? So I'm going to set that up because I'm going to use that game in several of these tests. Okay. So what are some things that I might want to then test? What are some test cases?
Numbers outside the range.
Numbers outside the range. That's one possibility. I'll come back to that one. What else? What else can possibly happen?
The range.
Huh?
The too high or too low, and then the correct guess.
Okay, so let's try the happy path first, which would be the correct guess. So we want to, let's say we do that. So public, I'm going to make a method here, and this is going to be that case. So public void correct guess. And so I might say this is I need to say this is a test. Okay. So I need to kind of set things up. I've started the setup here because I've already created a game. So the first step is always to do setup. And then the next step is to do what we call act. And the last step is assert. So every unit test you write, regardless of what language you're writing it in or what framework you're using, always follows that pattern. Setup, act, and then assert. So with the setup, we're actually there because we've done it up here. We've got nothing to do on that front. But from the acting side, I want to say, let's call the method in question. So I might say guess result is equal to result. And here I would say this is game dot guess, and then I might give it a number, right? So I might give it a number of, say, 5, right? So we're going to guess the number of 5. And so that will be the correct guess, right? So if the logic in guessing game is correct, what should result be right now?
A win.
A win. Okay. So I need to assert equals. And so we're going to assert that the result is guess result dot win. And I need a reference here. Oh, I misspelled it. That's why. There we go. So I want assert equals. That's the one I want. So I'm going to bring in that import.
Was that the first or the second one? Oh, it's the assert equals.
Yeah, look at the... Look at the name of the class.
Yeah, I got it.
So we're bringing in that method. Okay. So that will now let me test. Now that I've got a test in there, I can actually see if it works. So I can say right click in here, and let's say, or I can say run correct guess. It'll just run that single method. I'm going to go down here. I don't want to run the whole test suite. Okay. So we can see correct guess came out good. So that means our logic is correct. And so then I can proceed with the next test, right? So we've got one test there. What would be another test that would be good to write?
Probably just go with the high next.
Okay, that makes sense. So here I may make another test. So I say at test public void, and we say high guess. And so still my setup's kind of already done. So I just need to do the act stage. So what number should I give, though, here? Because I don't want to give 5, right? 5 is the correct guess. What number should I pick?
7.
Okay, so let's say 7. That's fine. And then for my assertion, right, looking at what we did previously, what do I need to what would I need to write as my assertion?
With high.
Okay. But I want to write assert equals yada yada, you know. So the expected value is the thing first. Or sorry, do I have this right? Oh, I have it backwards. The actual value should be second. So it should be guess win, and then it should be result. So it should actually be guess. Should actually be the expected value first.
Is there no setup?
There's no setup here because we did it in before.
Okay, so you would normally, you could duplicate your code and put what's on line 16 on line 22?
Exactly. I could put this line 16 in every one of these methods, but it would be redundant, right? So that's actually the purpose of having this here, is reduce the amount of code I have to write. Reduce redundancy. Okay.
Yeah, I noticed that assert equals can take another argument while I was fixing it.
Uh-huh. And so, well, remember we talked about floating point. If it's floating point, you need a third argument for the epsilon.
Right, yeah.
Okay. So that's a correct guess. That's a high guess. Obviously, the next one would be low. So I can modify that code a little bit and say this is low guess. What number should I feed into it?
3.
Okay, so we feed in 3, and we expect to get out low. So we're basically saying for this value, for this input, I would expect this output. And then I can easily run all of these tests just really quickly, like right there. I don't have to go manually test all those things. Okay. Any other cases we should track now? I think you said something about wanting to do the wanting to deal with the out of range one.
Yeah, that's right. And we're expecting, in this case, you'd write it to check that it throws an error because we're checking the business line.
Right. And so there's a reason I wanted to do this one last, because the way you check for exceptions is a little bit different. So here's the deal. So if I say, if I were to say pull any of these here, so I'm going to say, I need to mark this with at test. So guess out of range, and then I want to assert something, right? I want to say let's try 11 and see that it's whatever it is. This test is actually always going to fail. So the thing to remember here, I'm using code to test code, right? So I'm actually calling this function. Well, that function throws an exception. Am I catching that exception?
No.
No.
I'm not. So as it turns out, it never gets down to the assertion. It never gets down to the assertion because the code throws an exception. Okay. One piece of advice, and this doesn't matter what language you're writing in, you should never put a try and catch in your test cases. You should never put a try and catch in your test cases. So the way that we deal with that instead of using assertion, we add another annotation. And if I remember right, it is throws. And I may need to look that up here real quick. Although it may be rule, if I remember right, that we want to use. I think it might be the rule annotation. So let's see. Rule. And let's go into there. I forget. And I may have to look this up. I know it's an annotation, but I forget what the syntax is. So, see the Google. So, JUnit test throws exception. So, oh, there we go. Right. So it's part of the test annotation. That's where I couldn't find it. So it's test expected, and here I would put that illegal argument exception dot class. So in there I specify what kind of exception I expect it to be, and so that's basically my assert stage is this. And we can test that works. So for instance, if I change this to number format exception, try to run it again, you can see that it fails because it's the wrong kind of exception. So here I'd be saying I expect it to be number format, but it was actually a legal argument exception. Let me go back. So does that make sense? That's how you check for exceptions. Is you don't catch it, you just use an annotation. Okay?
Got it.
All right. Now, have we sufficiently tested the guess method now? Have we tested all of the logic in the guess method?
Well, you mentioned that we would test for things that weren't even possible, like maybe entering a letter.
Okay. Well, I can't do that because the interface, I can't try a letter because I can't try, because guess only takes an integer. But I could try like a negative value. Does that make sense? So I could say, let's guess negative. And then I would expect, if I say guess -1, I would expect that to give me a legal argument exception as well. And so I can test that even though I can't type -1 into the UI.
Well, how is that different than a letter then? Because you couldn't type a letter either,
Mm-hmm.
depending on how you set up your keyboard.
Well,
I don't know. You have it now.
Remember, what does this method accept? What does this method here accept? Int. So I can't pass anything that's not an int. That's
Okay.
the scope of what I can do. It can only take an integer. So in terms of the scope of what I can do is only things that are there. If that, for instance, took a float, then I could try numbers like 2.5. If it took a string, then I could try things like ABC. So I'm a little bit limited here on that. But that's good, right? I don't expect it to be anything other than a number, than an integer. So I should enforce that. Okay. So...
I got a question there on line 55.
Uh-huh.
Do we really need the left half of the equal sign?
No, you don't. You really don't. You could just write that in both of those cases. You expect it to throw an exception, and therefore you don't really... There actually will be no returned result. So that can be just guess 11 or guess -1. Okay. Now, again, coming back to my original my question, have we tested all of the guess method? Have we tested all of the logic there? Have we tested every if statement?
Do we need to test if they can enter nothing or if they enter nothing?
Well, can I pass nothing to this method? Remember, it takes an integer, right? So an integer is a primitive type, so I can't pass like null, right? Or empty string. Okay, so let's walk through it. And we're kind of thinking about in something called test coverage, right? Is our test covering all the logic? Right. So does our test cover this logic?
Yes.
Okay. Do we test both of those sides? Do we test lower than 1 and greater than 10?
Yes.
Okay. So we've covered that. Have we tested this statement here?
No.
No.
Okay. So we've actually got a gap in here because all of our tests that we've written don't do any checking on the guess count. Right? We haven't checked after any of these tests to see what the count was. Does that make sense? So what can we do to test those values?
We'd set previous guess and then have them guess that.
Okay. So set the previous guess and then have them guess that. Okay. So what are you saying? What should I call that test case?
Guess previous.
Or same as previous. Maybe?
Yeah.
Right. So at test public void same as previous. Okay. And so in this case, you're saying I want to say that I guessed the same number twice and it doesn't count it. Okay. So is there anything I need to do in terms of setup?
Have to set game to a new guessing game.
Okay. Do I? What would I do with the new case?
You would assign it a previous guess and a secret number, and then guess count would still be 0.
Okay. So here I might say game is equal to new game, and what's the first one? The first one is, say, 3, and one guess has been made previously, and the secret number is 5. New guessing game. Right. So if I say previous guess is 3, 1, and 5. Okay, so I've got it basically in a state of having made a previous guess. Right? Okay. So I've set it up. What would be my act step? What's my act step here?
Game.guess.
Okay. And what am I guessing?
The previous guess, so game.prev guess.
Okay. I don't wanna rely on game.previous guess because I don't know if that method is working, right? I don't know if the previous guess method is working because, well, what happens if that method says return 2? Right? Then my test is broken because this method is broken. Do you see that, Mo?
Yeah.
Okay. So you want to be very careful about your dependencies when you're doing that. So I actually want to repeat the number 3. So redundancy is good here. Does that make sense? You want your test to be in such a way that they only fail if the particular code that is being tested fails. Okay. So is that all I need to do for my act step? Do I need to do anything else?
Don't you have to set game that guess to a guess result?
Well, but what I could, but what's my assertion? What am I asserting in this? What was my whole point to originally check? So I said, let's guess something that's the same as the previous guess. What should happen in that case?
It would be
Guess count
Sorry.
the same.
Should be what?
Guess count would still be 1.
Okay. So that would be a good thing. So I want to assert that that is the case. So assert equals, and this is where I would say, game dot guess count. And there I do have to kind of rely on the guess count, the get guess count method being correct. There's not a way around that one. But then I can say I want that to be 1. So I can run those tests. And all of that should pass. So does that make sense? And I don't really need to test the result in this case, because my test, all I'm trying to determine is that the count is the same. Does that make sense? I've already tested basically that the results should be low, because that was a previous thing, right? I've tested that, so I don't really need to assert that it's low. Yes, it should be low, but if I then mix that in there, then I get a false positive or false negative on the test where it says it fails, even though it's failing for a different reason. Does that follow? If you put multiple assertions in a test, then it will fail if any one of those assertions is incorrect. So the guidance, the best practice in writing unit tests is you should only ever have one assertion. Okay? So you really should try to only have one assertion.
I have a question about the setting the new guessing game.
Uh-huh.
Wouldn't you be able to just put the 3 and the 1 in the initial new guessing game, since none of the other tests are referring to those values?
That's a great question. That is a great question. Could I? Is that going to break any of my other tests? Probably not. I think you're right. I think you're safe. You could put it up. You could put it up here, and then we could remove that step here. And so, if we run our tests again, I think all of them will pass. So they still do. Yep. So that's perfectly fine.
But then wouldn't you have to go back and change it if you wanted to make another test?
Not necessarily. Okay. So we said same as previous. What would be the reverse of that? What would be the opposite of that?
Different from previous.
Okay. So let's write that test out. So different from previous. Okay. So what number should I guess here? Somebody give me a number.
4.
Okay. So 4. And what should my count be then?
5.
Be 5?
I mean,
it says it's actually.
2.
I think it says it's actually 2.
oh yeah, it is 2.
Or actually, I have these. Did I get these reversed again? Yeah, I did get these reversed again. Because you see, it's saying expected to actual 5. The order you put them in does matter.
Oh, I thought you the count actually mattered. The expected.
Yeah. So sorry, the first one's supposed to be expected. The second one is actual. So this should be 2 like that, and 1 as the first argument. I think I switched those around on the other ones already. Yeah. I just lost track. So that's an easy thing to forget, is to put them in the right order. So does that make... Yep.
Yeah. Okay. So in before we set it to 3, 1, and 5, right? So that is, if we would identify it in the test like we had previously, that overrides it. Yeah.
if we had changed it?
Well, here's where I'm getting confused. Is the name of the game in the guessing game in the before
Mm-hmm.
test method up above was game.
Okay.
Game equals new guessing game 315. Okay. Now, if it's defined within, say, like different for previous, with different numbers, does that override it? Because it's not at a global level, or does before kind of put it there even though it's not?
So
It's not
yeah. It's a great question. It's a great question. So one of the things I can do is I can try to, let's put it here and let's see what happens. So let me put a line there, changes all those numbers to 0. Okay, so that one failed. But you're right in asking the question of, well, if this logic happens, does that then break, for instance, correct guess? Because correct guess is expecting that number to be 5. And I wonder if I maybe move it around. I'm not sure entirely which one's running first. I can see low guesses at the top of the list, and I'm going to guess that that's probably indicates that one's first. But let me just say I set it up here, and we run. And so what I see is that the other, low guess, high guess, those are not being polluted by this change.
So before is universal unless you set it there.
Before is always called before your test case runs. And one of the things we can see, I think if we do system.out.println, and I'm going to print before. I believe I can look at the terminal after this runs. So I'm going to tell it to write out before, run the program. And what you see, how many times did it run before?
Yeah, probably the number of methods that
Right.
it does it each time.
Yeah, so I've got 1, 2, 3, 4, 5, 6, 7 tests. And so it ran the before method before every test. It didn't just run it once, but it ran it before every single test.
So when we say game equals new guessing game within any of these correct guess, or it doesn't matter.
It doesn't matter. It doesn't affect any of the other tests.
What does it do in memory? Because we're constructing something new. So there are 2 spots in memory with the name game. That seems like that would throw an error.
Oh, no, that's happens all the time. That happens all the time. So remember that you've got this idea of a class and an instance of that class, right?
Right. The instance is named just game. Lowercase g. No.
Okay. You're not thinking broad enough scope. The instance, yes, there's an instance here of game, right? But there's also an instance of guessing game test. So what's happening here is it's creating a new, you can think of it as creating a new guessing game test every time it calls, every time it runs your test. So and kind of think of it at that space. In reality, it just calls, I think it just calls before. I don't think it actually constructs this every time. But it's saying every time it will run before, we'll say run this line of code, then run your test, run this line of code, then run your test, run before, run your test. And so every time it's creating a new instance of the game and saving it to this game variable. In reality, it's always saving it back to that same place in memory. But this place in memory is not necessarily one place in memory. It's just a place in memory for every test object that you have, right? So if I have 10 of these test objects, then I have 10 game variables. Does that make sense?
Yeah, but how would you differentiate between them? Just their spot in memory? That's the only thing that's the only thing that would make them different, right?
You don't. So First of all, you generally don't kind of need to differentiate.
No, you don't. But
so
it's just confusing to me why it doesn't throw an error.
Right. What you need to remember is anytime I'm defining a field, right, that field belongs to this object, this class that we're in, right? So if I have 10 of these things, they all have that same field with a different name but a different place in memory. Or to put it another way, if I go look at the game class, right, let's say I construct 10 games. How many previous guesses do I have now if I have 10 games? Do I have just one place in memory to store a previous guess?
Yeah, I think so, because it gets reassigned. No?
No. If I have 10 games, 10 guessing game objects, how many previous guesses do I have in memory? I've got 10.
10?
I've got 10. Because every instance of this class gets all of those variables. Gets all of those variables. So I may have only declared that variable once, but remember that that variable basically exists every time I create a new thing. So let's say I have transactions, right? If I have a balance in every one of those transactions, they're not sharing the same place in memory. Otherwise, all the balances would be the same.
Okay, but we only got one game at a time going here.
Yeah.
Right?
Yeah,
It's
as it turns
impossible
out.
to have more than one instance, right? Because you hit reset or you restart the program and then that's it. Okay. Well, I mean, I otherwise get it. So the least we need to know is that before is setting up the conditions ahead of time. If you don't set it, that's what's being used. But if you do define it, you can use the same name in the method and it will use that. But for the next method called, it'll go right back to before because it runs that first.
Yeah. So the whole point of the before is just to save us time on setting up. Because otherwise I would have had to write the same line of code, that line of code in every single test.
Okay, so it's kind of like you can customize it if you want, but that's kind of like your default template if you're starting out.
My starting data, my starting point. So in terms of guessing game, right? So we have tested the guess method. Are there other methods we need to test?
Reset.
Okay. So, all right. So let's see if we can test the reset method. Okay, so let's assume that setup is good enough, right? And so we've already got a game object that I can reset, and it's good because it's already got a previous guess, a guess count, and a secret number in there. So all three of those values are non-zero. What can I do for? What do I need to do for my act step? If I want to test the reset method.
We'd probably have to go with maybe put a number in there and then hit reset potentially.
Or what method am I trying to test?
Game.reset.
Game.reset. That makes sense. That's all I need to do because we've already set those numbers, right? So if you're thinking about that guess, calling guess before, that would be another piece of kind of setup, right? Okay, that's really all we need to do for our act. That's what we're trying to test. We're just trying to call reset, see what happens. So what do I want to then assert?
Oh yeah, okay.
Mhm.
About that, can you do more than one assert equals? Of course you can,
Yeah.
right?
Yeah, you
Just
can. It's generally recommended against, but you can.
Okay, so it'd be 2 lines of assert equals, and you put 0 for, and then previous guess, get previous guess.
Okay.
On
So
that side.
let's do it one at a time. What's my first assertion?
0, comma, game dot get previous guess.
Okay. So we're saying that if we reset properly, previous guess should have gone to 0.
Yeah, I believe that's right. Same thing for the guess count.
Okay. So assert equals 0 and then game dot guess count. Okay. Anything else that we need to assert? Anything else that should have been reset?
If we're going to use the default,
Mhm.
well, yeah, I forgot to look and see
So-
what reset does.
Okay, so those should happen. What about the secret number?
It's changed.
Okay. So what can I assert to say it's changed?
Can you check that it's in a range, maybe?
Wouldn't you have to save a variable before you reset it to so you can save what its previous state was?
Well, do we know its previous state?
It might end up being the same by coincidence, though.
Yeah, we do.
Right. Well, we know because we initialized it to 5, but you're also right. Paul, that it could be the same by coincidence. So I could say let's assert that it's 5, and let's say game dot get secret number. I could say, actually, I would say assert not equals, I think is the one that I want. So assert not equals, and let's, oh, no, I want to just run it. And so test reset past that time. Run it again, run it again, run it again. One of these times it should fail. But apparently I'm getting very lucky. Gee, why am I so lucky on here?
It just likes you.
I know. It's like this should be failing.
Well, you got 90.
There we go. There we go. There we go.
Wow, you had like a 95%.
Right. So that's a problem. And this sometimes happens. Honestly, sometimes you have things where the data, in some sense, is random-ish. And so here we've got a false positive where sometimes it fails, but most of the time it succeeds, right? And that's a problem, because we want from these tests, we want to know for sure that it actually worked, right? So what can I do? What can I do instead what can I do to fix this problem here? How could I work around it? I've got a few options. Right? So one option is I could just say, well, let's forget about the secret number and we'll just not test it. Okay. Probably. Huh?
Would you be able to test the spot in memory where it's at? Because that should never be the same, right?
It'll actually be the same place in memory. If it's the same place in memory. Because I'm just generating a new number, putting it back in the same place in memory. So the place in memory doesn't change. So I can't check the address. Now, what I can do, I can use a little bit of foreknowledge. Okay. So what do I know about the number that it generates? What's the range of that number?
1 through 10?
1 through 10. Okay. So here's what I can do. In my setup, what if I start with the game, say new guessing game, and what if I just set it up so that the current secret number is outside of that range? Well, then I know that it should be, I know that it shouldn't be 20. Because whatever number it generates has to be different from it shouldn't generate that number. Does that make sense?
Yes.
So that's one way to test it. That's not the only way to work around it, but that's one way to test it. And so, I can go back into reset. Let's just find out and check that works. So if I don't have that line of code there, okay, we can see we've got a broken test, which is what I want, right? I want, if the code is broken, then I want my test to fail. So sometimes you have to do a little bit of problem solving and a little bit of thinking about, well, how can I approach the setup to get it to where it needs to be. Okay. So is there anything else that could happen with the reset that I might need to test? So here's one piece. Now that we've done all that checking, does our code ever call this constructor? Do any of our tests call that basic constructor anymore?
Do any of our tests call it?
Do any of our tests invoke that constructor?
No, I don't think so, no.
Right? Okay.
Okay.
So I could break this, I could break that method, which would break my program, but none of my tests would catch it. Do you see that? So I've got a little bit of problem because I only use that before to set things up. So I do need to add another test in here, and I might do this before reset. I might say test init. And here I want to use that other constructor and test that things, got set up the right way. So my act step is really just to construct a new game, and then I want to verify that things are as they should be. So we might want to verify that the value is not 1. We might want to verify that assert greater than let me just see on the assert class. So we got assert equals, and And so there's not a greater than right there, but I can say assert true. So assert true, and let's say, actually, is there an, I feel like there's an assert that. Oh, but that one's deprecated. So assert true, and I might say assert true, and let's say that the guessing, the secret number should be greater than or equal to 1, and the secret number should be less than or equal to 10. And I want to bring in assert dot assert true. Values should be different. Oh, right, because I broke it. Right? So we put that code back in now. So does that make sense? You kind of have to test each method one by one.
How did you fix that again?
I had commented out the code in the constructor here, and so I just brought it back.
Where was the code you commented out?
It was in the constructor here, line 12 and 13 of guessing game.
Okay, I gotta copy that. I didn't have that for some reason.
Okay. Yeah, you should have two constructors. One that takes no arguments and another one that takes 3. Okay. So you can see how we set up these unit tests. And as you can, as I hope you can see, that the code of actually writing them is not that complex. Usually there's just one line of code.
Can you go back to that? I'm still getting an error. It's this rand. Okay.
Mm-hmm.
I think I'm missing the this. That's the problem.
Mm-hmm. So, I mean, unit tests are not really, in general, your goal with the unit tests is they should be dirt simple code as much as possible, right? So things like you don't want to have try catch statements in your test. You don't want to have any if statements in your test. You do not want to have any loops in your tests. You don't want to have any switch statements. The point is to have no logic whatsoever in that test, because one of the things you don't want to do is get a good, a pass or a fail because you made an error in your test case. Does that make sense? You don't want to have to debug your test case. Any questions?
Maybe you can work with me separately. I still can't get assert true to work.
Okay.
Dang, test cases are confusing.
Huh?
Test cases are confusing.
Oh. So you kind of saw, I if you look at the 3.2 sheet, here's what I've listed. I've said, here's the test cases to test. So for instance, I said, test -1, 0, 1, 10, 11, lower than a number equal to secret. So I've listed some test cases and what the expectation is. So for instance, here I've said, for some product, I've said, test when n is -1 and see that it throws an illegal argument exception, right? So one of the things that means in there, I'm implying with that, should all of your code be in your activity? Can you build these tests if all your code is in the activity? The answer is no, right? So you probably need to take your logic, right, and not just have the logic in the activity. You probably need to move it into another class, right? So you can test that class. Everybody with me there?
Yeah.
So I might, for this, I would say, well, let's create a sum product class, and that kind of has the logic of my application. Or create a prime numbers class, put the logic in there. Create a money tracker class, put my logic in there. And so, but it's, as you can see, it's not all of the logic. It's some parts of it. Okay. So that's what you have for the labs on 3.2. So one of the questions when you're kind of working through unit tests is, why should you write them and when should you write them? And that's a question that commonly comes up. To be fair, in my own personal practice, in my own projects, I don't usually write very many unit tests, if any. That's kind of on me and my side. So be fair, forewarned on that. They are a valuable tool, but they also come with some trade-offs. They can make your testing a lot easier and a lot quicker, and I think the market trend is towards having them as well. But there's also there's definitely some gotchas and different things along the way. So one of the things I want to do is play this video here, and kind of go through, because he makes a really good argument about why you should do it and when you should do it. But I think we need to take a break. So let's come back in, say, 20 minutes. So 2:55. We'll kind of watch that video, talk about it a little bit, and get on to lesson 3.3.
Yeah. Hey, Mr. Smith.
Yeah.
I think Zach's having problems like I am too. Can I share my screen? And then you can, yeah, okay. All right.
Yeah, I'd definitely like to hop in that and watch that and see what's going on.
Okay. So we can troubleshoot that here. Anybody else that wants to go on break, we'll resume at 2:55. But I will be here.
Okay. I don't know if you can see.
Popping in. Not in there yet. Okay. You just probably don't have an import. So if you go back down to it. Nope. Go back down to it. And go on the part that's red. Okay, then do Alt-Enter. And then it says import static method. Yeah, that top one. Problem solved. You're just missing
Oh,
an
okay.
import.
All right. I was just afraid to do that. All right. Easy enough.
Yeah.
All right. Thanks.
Yeah, we just hadn't imported that method yet because we hadn't used it. Zach, did you see any of that?
Yeah, I did, but I think I'm having different issues with mine. I'll my screen real quick.
See if we can sort it out. Okay.
Yeah, so my
yeah,
search
so-
true and
That's a different thing. So run your right click the class and run it. Okay. So your code is fine, but your test failed, right?
yeah.
Okay. So what does that mean? What does that mean? says there was assertion error, okay, and it should point you to a line of code there. What does it say? Line 87, right?
Yeah.
Okay. So that just says the assertion didn't pass.
Okay.
So that assertion didn't pass. Okay. So that's not a problem with your code. That says, okay, it found there's a bug. There's a bug in your guessing game. That means when you create a new guessing game, the secret number doesn't get set properly. And I see it. So why is your secret number not getting set when you create a new object?
Is it because I have my reset in guessing game also?
Where should the new number be generated? Go back to guessing game test. Okay. Don't run just that one method. You want to run the entire class. So if you go on the left pane, yeah, right click the class, that will run all of the tests. Yeah. So you see there's actually 2 tests failing, both reset and test init. Does that give you a hint?
Yeah.
Right? What would make both of those tests fail?
I'm trying to think here, and I'm just having like oatmeal brain.
Okay. It's in guessing game. What would make both of those 2 tests fail? Go look at guessing game. Okay. So we saw that the reset test failed, and we're also seeing that the init test, that constructing a new object, is failing.
Is it by chance that my secret number is equal to 0 also?
Nope. What does guessing game call in line 13?
It's reset.
Okay. So if there's a problem with reset, that would also cause a problem with error. Does that make sense?
Yeah.
So the problem's in reset. Because that's
Okay.
what's common to both of those. So go look at reset. Right? Both of them are failing for the same reason. Go back to reset. That's your test method, not your reset method. Where's your reset method?
Right here.
Right. So what is happening on line 46?
Oh, I commented it
A
out.
whole lot of nothing, right? So that's why both of your tests are failing.
It was because I commented out that one piece of code and didn't bring
Right.
it back in.
Yep, that's it. So try to run all the tests again, and that should go away. Does that make sense?
Yeah, it does.
Your tests are trying to catch things like that, right? So if you have an error, right? Yes, it could be the test, but generally speaking, if your tests are working right, then the test failing is a sign that there's a problem with your code, right? That's what it's trying to get you. It's trying to tell you, now you can run all these tests just by saying, well, run all those tests. You don't have to go manually test it in the UI every time.
Yeah. Okay. Awesome. Thank you.
Mm-hmm. Anybody have questions on this unit testing stuff at the moment? So when you get back, and if you haven't done this already, you can go ahead and commit this code.
The test init code. Can you go down to that? I had an error. I just ran the test and it failed. Okay.
You may check back into your guessing game. It might be a problem with your code in your guessing game. Which assertion's failing?
Shoot, I got 3 of them.
Mm-hmm.
That's not good.
Okay.
Uh,
So you might need to check your your guessing game and see what it's not doing, right? So this is trying to call the constructor and make sure the values are set correctly, right? So check the constructor is correct.
yeah, I'm getting different from previous. Why is that throwing an error?
Again, check your constructor.
Okay.
and you may need to use some debugging tools. You can run any of these tests with the debugger attached just by running the debug button like we did with Android code. Okay. So let's get back to it. So if you haven't yet, please go ahead and commit the code. So I'm going to commit the code that I have here and push it. And I'm going to call this guessing game version 3. And I'm going to say commit and push. So make sure you get your code up, submitted.
I still got errors I got to work through, but I'll push it up anyway.
Yeah, push it up anyway. And that'll take care of your attendance for today, too. All right, so what I'm going to do, I'm going to need to switch my screen share first. So as I kind of mentioned, I want to watch this video together, kind of about why you should do unit testing and you know why that's relevant. So this is going to be this guy's from a channel called Fun Function on YouTube, and he's had some really good stuff. Unfortunately, he's recently stopped making videos because of wanting to go back into industry stuff, but he's got some amazing stuff. This is related to unit testing in JavaScript. So you'll see kind of that you'll be in VS Code and using Node like we did last semester. But the principles really apply to unit testing in any framework, in any language. Okay. Everybody good? I'm going to hit play real quick and see if you can hear my audio. So just let me know if you can't.
And the world record is 11 balls, but nobody is even.
But I think that I may need to come back and log back in because I've got that banner hiding the video. There we go. Now I can get to my play button. Okay.
Close to handling 15. Good Monday morning. Today we're going to start exploring unit testing in JavaScript. I think of unit testing as a software development technique where you divide your software up into small isolated units and then you write automated tests for those that verify that each unit works as expected. My main motivation for doing unit testing is to keep complexity from overwhelming me. We're going to look at how a piece of code always starts out simple, but eventually grows in complexity until it is too much to keep in our heads. I am MPJ, and you are watching Fun Function.
That's not your friend. It is your friend.
So today's video is completely focused around why we do unit testing. So we are actually not going to be writing any proper unit tests today. We're not going to be at all focused on the what unit testing is or how we do it. We're going to start with why. And I want to start in this way because unit testing can be daunting. It can be daunting to learn, it can be daunting to do when you're under pressure, like a tight deadline, you just want to get your software out, or on days when you're just feeling lazy. In those situations, it's very important to know why we are doing unit testing, where it comes from, and what we're trying to achieve with it. Alright, so let's imagine that we are running an online pet store that specifically targets people who own small dragons. In the checkout and some other places, we are going to display the order total, a sum of all the items that we currently have in our shopping cart. Somewhere in the code base, we're going to have this function called order total. That function is given an order and it outputs a total amount of all the items that are contained in that order. Alright, success. Let me walk through this code for you. So we have this example order here called sum order. The sum order has an item property with an array of dragons that have a name and they have a price. The dragon cage is slightly more expensive than the dragon food. It costs 800 things. And here we have the star of the show, order total. It takes an order and it accesses the items property here, and it reduces all those items down to an order total by summing the price together. And then we call the order total with sum order here, and we get a result, and that is 108, which is 800 here plus 808. Did I say 108? 808. Huh. Hello, MPJ, your emotions here. I have not seen reduce before, and that makes me feel a little bit uncomfortable. I would rather use something that I'm used to, like a for loop. Hello, feelings, benefits here. It's completely normal to be afraid of new things, but remember that new things become less scary the more you use them, and reduce is super useful, and I really urge you to learn it. It will really change the way you think about things. We actually made an episode about that you can find by clicking there. Excuse me for chiming in here. I would just like to this here. I would like some alternate. Yeah, this is a bit nicer. Now it looks like a table, right? That's nice. Okay, that looks beautiful in that specific case, but it would break in the linter in any real project. That is just indentation that is useful in just this specific case. That's valid points, but this video is about unit testing. Can focus on that? Alright, fine. This example to me seems very examply. This order total function here, this is already a cleanly separated unit function. It's in real code, things tend to be a lot more intermingled. I feel like this is just a very theoretical example. Yes, this doesn't feel like real code to me. Sure, this is absolutely an oversimplified example, but this again is it's just an introduction to unit testing. Can we look at what the code looks like right now and what we could learn here? Alright, we can do that. I feel like this code order total, it doesn't need tests. It doesn't feel like it needs tests. It's very simple. Even with reduce, which I'm uncomfortable with because it's new, it doesn't feel like this is enough logic to warrant having an automated test suite. That seems like shooting a fly with a bazooka. Well, sure, it looks like that now, but even the most horrifyingly complex function starts out in a simple way. It's kind of like what's the expression? Boiling a frog? Or do you boil a lobster? Is it a lobster? You put it in cold water and then you just increase the temperature until... You know, that's a good point. Let's Let's try adding some complexity to this code. Let's invent some. Let's add quantity. Okay, so I've added a little bit of complexity. What can we talk about this? I feel like, well, I'm still not afraid of this code. It still seems very manageable. Maybe unit tests are a waste on simple functions like this. Or maybe that's a good point. Maybe they could be beneficial for us to pick our battles and not do unit testing on every single function and just save the time and not do unit testing on simple functions like order total here. People, you have to think about the old Swedish proverb. You have to think longer than your nose goes. That's not a good translation of that proverb. My point is that complexity is going to grow over time. What we see here, this is just one of 100 steps. Fine. Let's try that hypothesis and just add even more complexity. Let's invent. Let's add shipping, and if the order total is above $1,000, then shipping is free. Alright, so what did we do here? We extracted the total, like we started filtering the items first before doing the summing. So we sum only items that have that aren't shipping items, and then we find the shipping items in the array, and then we calculate the shipping if to be 0 if total items value is above 1,000, or the shipping to be the price of the shipping item otherwise. And then we add the two together, and then we eventually get the result down here. Now this is what I'm talking about. Things are getting more complicated now. Now that we added a conditional statement here, our code has multiple execution paths. Before, when we just had the price and we just had the quantity, our code just had one execution path. But now we have two. One where the order is large and we waive shipping, and one where the order is small and we charge shipping. Okay, so I think I'm starting to get your point. This code definitely got a little bit scarier now that we added shipping. Yeah, and I think I know why. It's because previously, before we added shipping, we could express the entire logic, or like what order total did, with just this, with just the sum order example. We had one example that expressed the entirety of what the function could do. But now, the example call, like sum order, can only tell half of the story, which is, in this case, that it's a big order. But if I change this to be quantity 1, we are now on the small order case. So this time it adds shipping. But the example can only express one of the forks in the road, so to speak. Yeah, I mean, I still feel pretty confident about this code. It's that's because I kind of executed this in my head while we wrote it. So it's only one other fork, one other branch in the logic. So it feels kind of manageable to keep in my head. But exactly. And let's say that we started adding more steps to the complexity over time. Like say that we added taxes or immaterial goods that require no shipping charges. Yes, then you can probably see how this would eventually get to a point where it's just too much for your brain to handle. All right, that makes sense. But if our goal is to think about less things at the same time, then couldn't we start breaking this thing apart into smaller functions? Breaking bigger functions into smaller isolated functions that are responsible for just very isolated things, that's generally a very useful tool, but I don't think it makes sense in this case. Order total seems like a pretty good unit to me. It seems like an isolated problem. In order to break things up into small functions, you actually have to be able to also break up the conceptual problem. Like if you just start extracting things out into lots of tiny functions, you're not really breaking the problem up so that you can think about it separately. You're really just spreading the problem out over multiple places so that you have to diverge your thinking even more. I think that you actually have to accept that even when a software module is small and isolated and minimal, it is probably still too big for you to keep it all in your noggin. Okay, yeah, but it feels like... Doesn't that mean that I'm dumb? It feels like a rockstar, super smart programmer would be able to keep this easily in their head. I understand where that feeling is coming from, but that kind of thinking just doesn't scale. If we have a software industry where the average developer can't build software of reasonable quality, then we are doomed as a world to have shitty software. And even if you are a software company that can afford and is capable of hiring the very best of the best, even their brains is going to get overwhelmed by complexity at some point. It's like with juggling. I can juggle 3 onions, okay? And maybe you are better at juggling. Maybe you can juggle 5, and the world record is 11 balls, but nobody is even close to handling 15 balls. Alright, so what did we learn here? Let's summarize. Code always feels very simple from the start, but it doesn't stay simple. It grows and grows and grows into multiple use cases. Too many to keep in our heads. Alright, I want to see what unit tests look like and if they can help with this. Which is what the next episode is about. You have just watched an episode of Fun Function. I release these every Monday morning 0800 GMT. If you are watching from the future, you can find next Monday's episode here. Otherwise, you can subscribe here so that you don't miss it. If you are forgetful, you can also turn on notifications in the YouTube app. I am MPJ. Until next Monday morning, stay curious.
Okay. So you've got some idea of what unit tests are now, and we've seen them in Java, and you kind of maybe have an idea of why they're useful and that kind of idea that, even simple code tends to get big at some point. It's still true that you don't necessarily need to test all code, and not all code can be tested. But it's worth thinking about, where are those places that you can test, that you will get the most bang for your buck, because, some of those things like that can scale and get more complicated. And in general, I would say, projects that you can do in like a day or two usually don't necessarily benefit a lot from unit testing, versus projects that take you like a week or more, are definitely places where some unit testing will really help you. Because as time goes on, you have more and more things that stack on top of each other, more and more complexity, and you have more code that you have to maintain. Okay.
The thing I'm not really getting is, I see how it works, but we got to build all that out. So if you got, say, a app that's I don't know, whatever, we'll say like, it's at an index of 100, then building out the unit testing might be like 90% of that difficulty level. You know what I mean?
Mm-hmm.
So
Okay.
it's like a little bit easier, but still, complex code requires complex unit testing that's just slightly easier.
Yeah. So, I mean, yes, they tend to get more. You tend to get more complex tests as you go on. On the flip side, usually you can, as again a general rule, you saw how we split up all of our tests into 3 steps: setup, act, and assert. Right. Even with complex code, you still follow that pattern. So what usually happens is that as your thing kind of grows, the part that actually gets the most complicated usually is that setup step. Does that make sense? The more data and dependencies and things that have to be in place, the more code that you might need to put in, say, that before function. Cool?
Mm-hmm.
So that's the one that usually scales the most. So if you can figure out how to get, stuff all the setup stuff, and use kind of a common starting point in that before, then usually you can cut those methods down to 2 lines. Does that make sense? So usually you can cut these down to like 2 or 3 lines of code, which is kind of the ideal. Anybody else? Questions? Before we go into 3.3. Okay. So remember, as I've said, there's no lab assignment for 3.3. You have a lab assignment for 2.2 and 2.1. Sorry, 3.1 and 3.2, but there's not a lab assignment for 3.3. Okay. So 3.3 is going to cover what we call the Android support library. And it's worth noting, a little bit of a disclaimer before we get into here. A lot of things have changed in terms of the Android support library. Following especially following 2018 or so. 2018 saw the release of Android 9.0 and Jetpack, and that's really invalidated or changed a lot of the stuff that's in this chapter. The other thing that's relevant there is a lot of the stuff that's talked about here and in the labs, etc., is things you have to deal with pre-Android 5.0. Which one of the big things that came there was material design in 5.0 and such. So some of these issues you're not going to run into simply because of our minimum API. Okay. The oldest version, the Google supporting of Android at the moment, I think is officially around 14. API 14, so they do go back a little bit further, but anything before 14 is basically at this point unsupported. So that's kind of in concert. So on the reading material, I have posted a few links to this page here, which is the main page that talks about the Android support library. And if you go to that documentation, you'll notice that there's a few different warnings, right? So one of the things you see here, do you see how in the back there's kind of this watermark that says deprecated in the background?
Yep.
So deprecated means that this isn't on a line of it's not been removed, but you're actively discouraged from using it. Okay, so fair forewarning. So that's there. It also says in here, there's another precautionary. It says, starting with support library release 26, which came out in July 2017, the minimum support for all of this is actually API level 14 or Android 4.0, which is a little bit different than what it says. So there's that, and then there's also finally a note all the way up at the top. It says with release of 9.0, this basically been replaced by Android X. So it used to be that all of these support libraries lived under android.support.star, but now they live in Android X. And there's a process that you can go through if you have existing projects that were on that older version, then you can migrate them to Jetpack. If you create a brand new project in Android Studio today, it will already be running in Jetpack. So you don't need to do that migration process unless you have an older example application. Okay? So a few disclaimers there. So let's kind of talk about, contents here. We're going to talk about what the support libraries are, some of the features, some of the libraries that are there, and how to kind of integrate them and use them. So the support libraries exist as a way to provide features features that may have not been available on older devices. So maybe rewind back. Every time we get a new version of Android, there's new features in that new version, right? And a lot of times those new features are not there. They never existed on a previous version of Android. So for instance, in a relatively early version of Android, we got something called a fragment. Fragment's sort of a mini activity. Well, that didn't exist in previous versions, so there wasn't any support for it. But you can use these support libraries. They provide implementations of those newer features that work on older devices. Does that make sense? So it provides a way for you to use newer features on older devices, backporting newer functionality to older devices. Everybody with me?
This is just for development.
Huh?
This is just for development then?
What do you mean just for development?
Well, it says Android support libraries, right? So if I got an old device that's running like Jelly Bean or something, this doesn't apply to that. This is just the development framework.
This is for the developers. So it means that the developers can write and implement certain things that were introduced, for instance, in maybe Android 6.0 on that Jelly Bean device. Right? They can use a feature that didn't exist on Jelly Bean on Jelly Bean. That's why that's
okay. Okay. All right.
So it's for you to be able to continue using new features. Otherwise, Android development would have stagnated back in like Android, back in KitKat, basically. He's like, well, I can't build, or whichever version of Android, I can't use all these features, which actually still has been an issue. I can't use all these new features because most of my users don't have that version of Android yet.
Yeah, just to make sure that the devices that are out there are still usable.
Yeah, still usable. But it is for developers. So it's not like if I have an app that wasn't built to, that didn't use these support libraries or things like that, I'm not necessarily going to be able to get that without developer support. Anyway, so things that are included in there, backward compatible versions of a bunch of different components, those being views or other controls. Additional layout and UI elements such as the recycler view was a later introduced feature, which is an amazing tool. The recycler view, and even we've already been using one of those layouts that's newer, which is the constraint layout. The constraint layout is actually never part of the core Android APIs. It's actually always was shipped as a part of the support libraries. It's now the default layout, and it's great. Constraint layout is awesome, but it's considered part of the support libraries and not part of core Android. Okay, but because it's there, you can actually use because it's in the support libraries, you can use it on on a wide variety of versions of Android, and not just the latest version that it's shipped with. Sometimes I can help you with different form factors such as TV, wearables, and one of the interesting things before 5.0 saw the introduction of material design and animations and a lot of other animations, transitions, a lot of those things. You couldn't, out of the box, you couldn't do any of that pre 5.0. So the support libraries provide some ways to do those things on, say, a KitKat, a 4.4 device. So that can be very helpful. So there's a lot of things in here. Backward compatibility. You generally always want to use the support library for something if it's available. It's generally considered good practice to use the support library over just using the platform specific one that might have been built in. So that way you have backwards compatibility. And so, one of the things we don't want to do is create different versions for different versions of Android. We want to ship one version of our app that works for all of our customers. I don't want to say, let's ship a version of the app for 5.0 and a version of the app for 6.0 and a version of the app for 7.0, on and on and on. That would be a lot of maintenance, right? If I've got, we're talking about from 21 to 30, we would be shipping 10 different versions of our app if we had to ship a different version, a different build for every version. That would be a huge overhead. So instead, we kind of want to use these support libraries and only use the best way for that particular API level. So historically, the support libraries used to support all the way back to API level 9 or 2.3. Nowadays, the bump, and you kind of saw that on the deal, is now they've actually gone up, and they only support down to they bumped up to they only support API level 14, which is a little bit different from what it actually says. So things that means, since the bump up to 14, since the minimum version that all of these support is actually 14. It used to be that there was and there still exists, there's a version 4 support library and there's a version 7 support library. Both of those, it used to be that version 4 supported minimum level API 4, version 7 used to support the minimum level API 7. Both of those are minimum API 14 now. And that being said, both of those actually shouldn't be ones that you use. Instead of using the version 4 compat or the V7 compat, we'll actually be using the Android X or the Jetpack equivalent of that instead of either of those two. Okay, so you used to kind of have to pick and choose and choose between either version 4, being able to go down to version 4, or going down to version 7. The only choice that you make now is just, hey, we'll use Jetpack. So in those versions 4 support libraries, That basically gave us, the farthest back in time, because you could go back to API 4 with that, and so broad variety of components and programming things and UI. A few of the commonly used ones back from that time include the compat, which is a lot of compatibility library wrappers and things like this. This is the one that actually, if you look at the 3.3 code labs, this is the one that it asks you to look at, is things in the compat library. So they've got compat, they've got core utils, core UI, media compat for media on older devices, fragment. Version 7 included even more than some newer features. So backwards compatibility, including all the version 4 stuff, TV specific, other UIs. Google Cast support was one of those things that was introduced later. So this support library gives you it all the way back to version 7. Color palette preferences. We'll kind of talk about settings later. But that was another thing that was introduced later on in the process. So there's a lot of different libraries that are out there, including, there's I think we were kind of mentioned, you're asking about, well, is there cards? Well, there's a card view support library that came with material design, and that's also there as well. So there's a lot of different packages that you can use and bring in kind of piecemeal. Now, it used to be that the way that you brought those in would be that you would add this to the Gradle. So in the Gradle, I would say com.android.support appcompat v7. This would kind of be my dependency. So that would be how I would write it. And so there was some kind of interesting things here. So version 7 was kind of somewhat your minimum. Realistically, it was 14. And then this 27 corresponded to the version that you're actually building for. So I was saying, this would be saying that I want to support at minimum 7 and at most 27. So that used to be the way that the kind of the version numbers and the things went into your Gradle. So we'll look at here, when we get done with this, we'll kind of look at what the newer syntax is. But that's basically where it ends up. It ends up in your Gradle. That's where the support libraries are brought in. So this appcompat library includes the appcompat activity. And if you remember right, every time we created a new activity, what's been that base class? A base class of every new activity we've created is that appcompat activity. So that's kind of where that comes from. Okay. So any new project you have, any new project you create will actually automatically include that appcompat library. That's just brought in by default. Same thing with constraint. Constraint layout's brought in by default nowadays. You don't have to do anything to bring that library in. You may have to update it every once in a while, but you don't have to bring it in because it's already there with a brand new project. So you can look at the complete list of libraries. You can see them at this link here, or you can follow in and see. The better place to look is then to go over to migrating to Android X, and that'll kind of show you how things translate between the old support libraries and the new packages. So like if we were looking at appcompat, there's a big table here, and let me just do a Control F and look for appcompat. So the old name, if I was going to add it to my Gradle, would be com.android support:appcompat version 7. The new place that exists in Jetpack is going to be androidx.appcompat:appcompat. So that you can kind of see the names are very similar. Most of the time, the transition is pretty easy, except for some of the material design pieces. It's definitely different there, but most of these are pretty similar. Okay. So you can read up on all the packages in the documentation about what's available. So to use the support libraries, as I said, you kind of have all of some of them already. It used to be that the way that you downloaded to use the support libraries, you actually had to do a two-step process. First, you had to download the actual code using the SDK manager, and then you had to add it to your Gradle. Nowadays, that option in the SDK manager has actually been removed. So you don't have to go into the SDK manager to download anything, and in fact you can't. If you go to look for what it shows here in the SDK manager, you won't find it. It's not there anymore. So it used to be, for instance, if you wanted to use constraint layout or recycler view, you had to go into the SDK manager and download those components, but you don't have to do that anymore. All we have to do is just include the relevant dependencies in our build.gradle file for the module. So we used to get through that through the SDK manager here. It was sort of an option here. You can see how this is under support repository. You remember looking at SDK tools at the beginning of the semester?
Yeah, that's right.
So we downloaded a few things from SDK tools. But if I look there now, I can go to tools, tools SDK manager, and I go look up there. See, it's not listed anywhere in here, right? So that used to be in here. That used to be something I had to require my students to download, but nowadays it's not there anymore, and you don't need to go do that step, which is great, because those are actually usually pretty slow. And my experience with that over the past few years is I ended up having to basically download the support repository for almost every project I opened, which was not the greatest thing, and used up a lot of disk space because of that. So the way it works now is a lot easier. So the only thing you really have to know is to add the appropriate dependency to the build.gradle module file. It'll kind of look like this: implementation, the name of the package, and the version. And then you'll have, you may need to update the version number. It might prompt you, and then you'll just hit sync now. So in the old kind of fashion, you might have something like this, dependencies, and it would look like so. Okay. So I just want to show you what that looks like now using Jetpack. If you've built a new project, which we did, we have this guessing game that we just got finished with. If I go into the build.gradle and note here I'm on the one that says module guessinggame.app. If I go down towards the bottom, does everybody see this section called dependencies in your file?
I don't think you have it up right.
Oh, I don't. I need to switch. Change windows. Sorry about that. So I've got the guessing game still open. I went over to build.gradle here. So module guessinggame.app. Okay. And
Are we watching or following along?
You can do either. I'm not actually going to change any. I just want to show you where it is. So in this project, you see the lines that say, there's 3 lines here that say implementation.
Yep. Mm-hmm.
So, and you'll notice that 2 of these, like Android X App Compat, Android X Constraint Layout, all 3 of these are libraries that are now part of Jetpack. They used to be part of the support libraries, but the newest versions are over in Jetpack. So this is the way you bring in the AppCompat library now. It's just androidx.appcompat, appcompat 1.20. And that's what you'll see there. That's where all the activity AppCompat is coming from, is from that dependency there. Constraint layouts coming from there, and any material design components that we might have are coming from that package as well.
All right, so this is automatically put in there, and
Yeah.
while it's not part of the base Android. You pretty much can't use it without it, right? You
Yeah.
have to have the stuff, and we don't really need
Right.
to import it or to copy it in. It's just
Yeah.
for knowledge of knowing where it is.
Yeah. It's basically this is where it is. And yeah, so most of the times nowadays, we really don't have to do much with it. You might occasionally need to use a compatibility class for things that have changed from version to version. And so, for instance, you saw that we used the share compat dot builder thing when we were creating that share button. So that's one of those support library classes. So as far as the support libraries are concerned, that's, you want to know about them. You want to know that they exist and that you're using them. There's a lot of things that are not part of Android that are there that are amazing, that will, really needed for doing modern app development. But for the most part, basically all of this stuff kind of happens behind the scenes. So you used to have more, because of kind of issues with pre 5.0, between version 1 of Android and version 20 of Android, they made a lot of changes and a lot of mistakes in the UI, in the API. There are a lot of oversights, and that's a lot of where the app compat, the compatibility libraries came in, is because a lot of just basically bugs or oversights of methods that should have been there but weren't in the libraries. Okay. So that's basically all you need to know. This is how you bring them in now with Jetpack. Is that they're basically already brought in. Okay.
All right.
So we'll be using some more of those as the semester goes on, but that's the vast majority of it. I do want to quickly show you. I'd posted these up. There's some videos that just a quick intro that Google did kind of about what Jetpack is, and where that fits in. Yeah. So basically, all I want you to know is there are compatibility libraries. They're used for supporting older versions of Android, and they now live in something called Jetpack. That's kind of the gist of today.
We're introducing Android Jetpack, our next generation of components and tools, along with architecture guidance designed to help you accelerate your Android development. You told us it was hard to do backwards compatibility, so we built the support library. You told us it was hard to manage your app as data changes, so we built the architecture components. And we heard you wanted more, so we're building more.
Android architecture components gives us a template to write production-ready Android code, which helps us onboard new developers faster.
Jetpack is made up of components in 4 categories: foundation, architecture, behavior, and UI. Each component is individually adoptable and built to maintain backwards compatibility.
We lost sound.
Android architecture components very modular.
We were going off of the sound from your mic.
Tinder and Zillow. All right.
Yeah, sorry, that was happening. Let me switch there. Yeah, so there's basic, anybody that's anybody is using Jetpack now. This video is about 2 years old at this point, but really kind of drives home some of the shift that's happening. So Jetpack is a really, really important thing in terms of the Android ecosystem, which is newer than this material. So kind of take that with a grain of salt and understand that most of the material in the textbook was written pre-2018.
Architecture components very modular. So we're allowed to pick and choose what feature sets we want that are applicable to our app.
Lifecycle-aware observers and observable components allow for a separation of concerns that create testable, robust, high-quality apps.
one of the most important things that we don't have to worry about is what code goes where. So that helps us unit test the view models. It helps us build robust code. We do not have to be lifecycle aware, and just helps the new devs come in and then write a proper modularized production ready code without having to add all of these extra defensive checks.
It also takes advantage of Kotlin language features that make you more productive. Jetpack manages tedious activities like persistence, background tasks, navigation, and lifecycle management, so you can eliminate boilerplate code and focus on what makes your app great.
Database persistence has been a nightmare for the Android community for years, and Room is a huge improvement. And Room was thought out with testability in mind, so we're able to add test coverage that we weren't able to before on our persistence layer without having to build any infrastructure around that.
With Android Jetpack, we're eliminating whole classes of issues and making your code easier to maintain.
Since Zillow has been using Android architecture components, users have been experiencing a lot less bugs in the app.
We'll keep adding new functionality to Jetpack across the entire Android surface. It's easy to get started. You can update your own app at your own speed, and all these components will work on older versions of the platform. Learn more and get started at developer.android.com/jetpack.
Take flight. To get Android Jetpack is here to accelerate Android development by facilitating a modern app architecture, eliminating boilerplate code, simplifying complex tasks, and providing robust backwards compatibility.
Jetpack consists of architectural guidance supported by a set of libraries and tools in 4 key areas of Android development: architecture, UI, behavior, and foundation. Each Jetpack component is individually adoptable, but are built to work well together.
Jetpack builds on the popular architecture components we introduced last year. These components facilitate a highly testable, robust app architecture while individually addressing developer pain points, such as lifecycle management or data persistence. We've also added 3 new architecture components: paging, navigation, and work manager. Paging facilitates gradual on-demand data loading from a local or network data source, allowing apps to work with large datasets, including support for Recycler View.
Navigation provides a framework to build app flows that comply with Android design guidelines, with proper behavior for up and back buttons, support for deep linking, automated fragment transactions, support for the overflow menu, navigation drawer, and bottom navigation. This is combined with a powerful graphical editor included in Android Studio to allow you to visualize, design, and test app navigation graphs.
Work Manager makes it easy to schedule one-off or periodic asynchronous tasks. Tasks can execute in order, in parallel, or in even more complex configurations. It's also easy to query for the state of tasks and to provide constraints, such as requiring unmetered network or charging. Perhaps most importantly, Work Manager takes care of compatibility issues, so you know that no matter what platform the user is on, tasks are scheduled efficiently and with system-wide health in mind.
UI components like animation, transitions, layouts such as constraint layout, text, emoji, and fragments, along with the TV leanback library, the Where UI library, and the Auto library are now part of Jetpack.
Behavior includes support for evolving Android areas such as notifications, permissions, and sharing. Jetpack adds support for slices, which allow your app to expose templatized pieces of itself to integrate with other apps, such as Google Search and Assistant.
Foundation includes AppCompat, libraries for automated testing, and new Android KTX Kotlin extensions, which make Android development with Kotlin more concise, idiomatic, and modern.
And we're just getting started with Android Jetpack. We have a roadmap of useful libraries and tools in development to help your Android projects take flight. To get started, check out developers.android.com/jetpack.
So that's a place that I'd really stress to maybe go looking for some of the new stuff that's underway. Is androiddevelopers.com. Jetpack. There's a lot of stuff up there about the what's new and what's coming with Jetpack. So we'll be touching on some of those things, some of what's new as we go through the course. But there's just a lot of things that are evolving and changing right now that are, beyond what everything we can touch. Okay.
Yeah, right. So we're pretty much using it already.
You're pretty much using it already. That's the thing to be aware of, and we'll kind of integrate it as we go. So you may see things that are like, we'll use your package name may be a different name than what it shows in the code lab, for instance, for some of these. And I think lesson 5.2 is the biggest one where those things are different. So cool. Any questions? Support library related, unit test related, lab related.
Yeah, tomorrow. So we got in classroom. Can we come up there early and start working on it? How early can we do that?
Sure thing. I should be up there by 10 at the latest. So the classroom will be open. There's also a student in there that's been using a desktop because he doesn't have a laptop. So it's pretty much open all morning. So.
Okay. Yeah, I just I haven't started on the final problem.
Okay.
I've just started drawing that up, but it's like, yeah, a lot more complex than the other one. And I'm just thinking I haven't even started that, and I gotta convert these over to unit testing, which pretty much I pretty much got to revamp my entire code. I mean, I feel like I got like 5 projects in front of me here.
Yeah. I'm sorry, but you recognize that. I mean, I like Thursday, Friday, both the next 2 days. I've opened those up as lab days. So, and I hope that at least the example that we got to today has really helped to understand what you need to do there.
Yeah, I hope so. I can only know once I try, and I got my code in that as an example, and I try to dig in. I mean, it seems to make sense, but yeah, it doesn't always.
Yeah. So both Thursday and Friday, strictly lab days. Monday will come in and you'll do your first test. So, and you can expect that hands-on test to be around the difficulty of that third of the money tracker kind of thing.
Okay, so everything will be turned in for the weekend then, yeah?
Everything should be turned over the weekend, turned in by the weekend, so. I think on, let me just double check. I can't remember if on Inside Ranken I set the due date as Sunday or if I set it as Friday. I think I set it as Sunday, but I don't remember for sure. Yeah, so the due date is Sunday, so if you have a little bit of time over like Saturday, you can continue working on that, but I would just say, try and shoot to get it done Friday if you can. Anybody else? Questions? Questions on the material?
Not at the moment.
Okay.
I'm good.
Okay. So you guys can go off and work on the labs, and I'll hopefully see you tomorrow in class.
All right, thanks. Bye.
No problem.
Oh, I got my wireframes I want to show you here in a bit.
Okay.
Maybe like 10 minutes. Yeah. I just have the main window so far, so it'd be, like 5 minutes.
Okay.
All right.
Then.
Okay.